Picture this for a second. A company ships a model with 2.4 trillion parameters, and on the same day, puts the weights out in the open. Not a stripped-down version. Not a demo build with half the capability quietly disabled. A full flagship, max-class model, the kind labs usually protect behind the tightest walls they have. This isn't a hypothetical. It's exactly what Alibaba Cloud just did with Qwen3.8-Max. And if you've been following the large language model race even casually, you know how rare it is for a flagship at this scale to go open. Until now, models at this size, Kimi K3, Claude Opus 5, stayed closed systems, locked behind API paywalls, rate limits and pricing pages that only make sense once you're already committed. Every serious competitor to those two names has, so far, either been smaller, weaker, or just as closed. Qwen3.8-Max breaks that pattern in one move. Today we're breaking down what's actually inside it, how it stacks up against the market leaders on the benchmarks that matter, why the pricing could rewire the economics of running AI at scale, and what it means that a model this large is about to be downloadable instead of rented. Here's the trick, and it's worth slowing down on because it's the whole reason this model can exist at this price point at all. Qwen3.8-Max doesn't fire up all 2.4 trillion parameters for every token it generates. It's built as a sparse mixture of experts architecture. Under the hood sits a massive pool of specialized expert subnetworks, but generating any single token only routes through a small slice of that pool. For Qwen3.8-Max, that slice is 95 billion active parameters. Do the math. That's under 4% of the total size actually switched on at any given moment. This isn't a power cut, and it isn't a shortcut either. It's a deliberate engineering trade-off. The model stores knowledge at a scale that rivals the heaviest flagships on the market, while computing at a latency and cost that's much closer to a far lighter system. That's the entire bet behind mixture of experts, size for knowledge, sparsity for speed. Now stack the rest of the spec sheet on top. A 1 million token context window. That's not remembers the last few pages of your conversation. That's the ability to hold an entire code base, a 100-page legal contract, or an hours-long meeting transcript in memory at the same time, with room to spare, and a maximum output of 131,572 tokens in a single response means the model can produce a full technical document, a detailed multi-stage agent plan, or a long research write-up in one continuous pass, without being artificially chopped into pieces and stitched back together. The numbers don't lie, but you have to read them carefully, instead of just reacting to the headline. On Terminal Bench 2.1, the test that measures how well a model handles agentic tasks inside a real command line environment, Qwen3.8-Max scores 86.6%. For comparison, Kimi K3 hits 88.3%, and Claude Opus 5 hits 89.1%. There's a gap, yes, but it's fractions of a percentage point, not a chasm you'd notice in day-to-day use. On DeepSWE v1.1, the benchmark built around complex engineering work and real-world software engineering tasks, the gap widens noticeably, 56.6% for Qwen versus 67.5% for Kimi K3, and 68.8% for Opus 5. This is where you can actually see the seam. Deep, multi-step refactoring of large, messy, real-world repositories is still a zone where the closed flagships hold a real edge, not a marginal one. But then look at humanity's last exam, with tool use. A test specifically constructed to break even strong, well-resourced models on genuinely hard, cross-domain reasoning. Here Qwen3.8-Max delivers 56.2%, essentially tied with Kimi K3's 56.0%, and only falls meaningfully behind Claude Opus 5's 64.7%. Put those three results side by side, and a pattern emerges instead of a single verdict. This isn't a model that beats the market outright. It's a model that closes to arm's length of the leaders on 2 out of 3 fronts, and does it while charging a fraction of what they charge per token. Break the results down by task type instead of by a single leaderboard number, and a clearer picture starts to emerge. The model's reasoning mode, extended logical chains with explicit, step-by-step thinking laid out before it commits to an answer, performs confidently and consistently, especially on tasks that require tying multiple data sources together into a single coherent conclusion, rather than answering from a single isolated fact. Multimodal analysis is another strong suit. Working across images, tables, and mixed content isn't treated as a bolted-on feature here. The model doesn't just see an image and describe it. It actually folds that visual information into the broader chain of reasoning alongside the text. Autonomous tool use follows a similar pattern of solid, dependable performance rather than spectacular outlying results. But where you need deep, highly specialized engineering coding, multi-step changes threaded across a large legacy repository, where one wrong assumption cascades and quietly breaks a dozen files you didn't even touch directly, Qwen3.8-Max falls behind Claude Opus 5 by the widest margin of any category we've looked at. That's an honest trade-off, not a hidden flaw. A model that matches the leaders on roughly 90% of everyday real-world workloads, but hasn't yet taken the crown in the single most demanding, highest-stakes engineering niche that exists in these benchmarks. Now for the part that could actually flip the market, and it has nothing to do with a benchmark score. Through Qwen Cloud and Open Router, Qwen3.8-Max costs $2 per million input tokens and $6 per million output tokens, with cache reads priced at just $0.8 per million tokens. By independent estimates circulating since the announcement, that works out to roughly 2.5 times cheaper than Kimi K3 and more than 4 times cheaper than Claude Opus 5. Sit with that ratio for a second. Think about what it means for a startup running millions of requests through a model every single day, not as a one-off demo, but as the backbone of a live product. A 4x difference in cost isn't savings you notice on an expense report at the end of the quarter. It's the difference between a feature that quietly loses money on every user interaction and a feature that scales cleanly as usage grows. For agentic pipelines specifically, where a single user-facing task can chain together dozens of sequential model calls, plan, search, reason, verify, act, re-verify. Every fraction of a cent saved per token compounds hard with volume. A workflow that costs $1 to run on one model might cost 25 cents on the other, and multiplied across 1 million daily tasks. That's not a rounding error. That's the line between a product that ships and one that gets shelved. That's why price, and not just the raw benchmark score sitting on a slide, is becoming the deciding factor when engineering teams actually pick a model for production rather than for a demo. And here's the most unconventional part of the whole story. Alibaba has stated that the weights for Qwen3.8-Max, along with a smaller, more accessible Qwen3.8-27B version, will be released on Hugging Face and Model Scope. That makes Qwen3.8-Max the first model at the Max flagship class to have its weights made available directly to the community, rather than gated entirely behind an API. Sit with why that distinction actually matters. A closed model is a black box you access through an API call. You send a prompt, you get a response, and you pay per token forever, with zero visibility into what happens in between, and zero ability to run it without an internet connection to someone else's servers. Open weights flip that relationship entirely. You can deploy the model on your own infrastructure, fine-tune it on your own proprietary data for a narrow use case it was never specifically trained for, and embed it inside a system where sensitive data never has to leave your own perimeter in the first place. For finance, for healthcare, for defense and government customers operating under strict data residency and compliance rules, that isn't a nice-to-have feature. It's often the only scenario under which a model at this capability level can be used legally at all. The compact 27B version, meanwhile, opens a second door entirely. It gives teams without a data center scale infrastructure budget something that's actually runnable on far more modest hardware, without asking them to compromise all the way down to a genuinely small, weak model just to get something they can self-host. Benchmarks are useful, but they're also a controlled environment. Clean prompts, known answer formats, no ambiguity about what success even means. Real work is messier, and that's ultimately the test that decides whether a model earns a place in someone's actual stack. Run Qwen3.8-Max through a batch of everyday engineering tasks, writing a function against an ambiguous spec, summarizing a long thread of scattered internal documents, planning out a multi-step agent workflow that has to call 3 different tools in the right order. And the picture the benchmark suggested largely holds up. Straightforward reasoning and synthesis tasks come back fast, coherent, and correctly grounded in whatever long context was fed in. Multi-tool agent tasks execute reliably, with the model correctly sequencing calls rather than skipping steps or hallucinating a tool that doesn't exist. Where it starts to show strain is exactly where the benchmarks predicted. Deep, sprawling refactors across many interdependent files. The kind of task where a senior engineer would want to review every single diff line by line before merging anything. That's not a disqualifying weakness. It's a signal for where to route which kind of work. Use it as the default workhorse for the huge volume of everyday agentic and reasoning tasks, and keep a heavier, pricier model on standby specifically for the narrow slice of work where the extra few points of engineering accuracy are worth paying 4 times as much for. Put it all together. Benchmark results that sit close to the leaders on agentic and reasoning tasks. A 1,000,000 token context window. Pricing several times lower than the closed competition, and open weights on top of all of it. And you get a model that isn't aimed at most powerful at any cost. It's aimed squarely at powerful enough to cover the overwhelming majority of real product, workloads, and cheap enough that running it at scale actually makes economic sense, instead of eating your margins. For teams building agentic systems with high call volume, support automation, document processing pipelines, multi-step research assistants that fan out across dozens of subtasks, a 4x price gap set against a 2 to 3 point quality gap can be the single deciding factor in a build versus buy conversation. That doesn't mean Claude Opus 5 or Kimi K3 suddenly lose their relevance. For tasks that demand the absolute ceiling of quality, especially in deep, high-stakes engineering coding, the benchmark gap we walked through earlier still clearly favors them, and no amount of price advantage changes that math for a mission-critical codebase. But the arrival of a model that's strong, cheap, and openly available all at once changes the underlying structure of the market itself. Developers now have a real, credible third option, not just a single closed flagship at a single price that they're forced to accept because there's nowhere else to go. It's worth zooming out beyond any single model release here, because this is bigger than one company's product announcement. When a flagship at the Max class goes open, it isn't just a price drop for one line item on somebody's cloud bill. It's the commoditization of an entire layer of technology that used to be a genuine moat. What was a closed lab's core competitive advantage a year ago turns, almost overnight, into infrastructure that anyone with a GPU cluster and some patience can pick up and build on. That accelerates research worldwide, because thousands of independent teams, universities, and smaller companies now get direct access to a model at this caliber for fine-tuning, red teaming, and experimentation. Not just the handful of large companies who could previously afford a serious API budget and the legal review that comes with it. But there's a flip side worth naming honestly instead of glossing over. Control over how a technology at this level actually gets used loosens right along with its accessibility. Once the weights are out, there's no recalling them, no revoking access, no shutting off a misused endpoint. The question worth sitting with isn't whether this particular release is good or bad. It's what happens as this becomes the norm, rather than the exception. Once the most powerful models in the world stop being a privilege guarded by a handful of labs and start being a file you download over a weekend, who actually ends up setting the rules for how that power gets used? None of this is a finish line. It's a checkpoint in a race that's clearly still accelerating. Alibaba has already signaled that the compact 27B variant is meant to widen access rather than sit as an afterthought, which suggests a roadmap built around multiple tiers rather than a single monolithic release. Expect the gap on the hardest engineering benchmarks to keep narrowing with each iteration, not because closed labs will stand still, but because open releases invite a much larger pool of outside contributors to probe weaknesses, publish fixes, and push fine-tunes that feed lessons back into the next version faster than any single closed team can move alone. Expect pricing pressure to keep flowing downhill too. Once one major flagship-class lab proves that a model this capable can run this cheap, the other labs in this race don't get to ignore that number on their next earnings call or their next pricing page update. And expect the open weights move itself to put pressure on competitors who've built their entire business model around keeping their best model locked behind an API. Because once developers have tasted the flexibility of self-hosting, deploying offline, and fine-tuning without a rate limit or a usage cap, going back to a fully closed system starts to feel like a step backward, rather than a premium upgrade. So where does that leave things right now? Today, Qwen3.8-Max isn't the single best model on every benchmark that exists. It doesn't claim to be, and the numbers we walked through make that honest gap clear rather than hiding it. What it is the first Max-class flagship that combines near-frontier performance, a genuinely massive context window, a price tag several times lower than its closest rivals, and open weights that let anyone actually own a copy of it instead of renting access one token at a time. That combination hasn't existed at this scale before, and it's already forcing every other lab in this race to answer an uncomfortable question. If a model this capable can be this cheap and this open, what exactly is everyone else charging 4 times as much for? We'll be watching what happens over the next few release cycles, because the gap we measured today is very unlikely to be the gap that exists a year from now. What do you think happens first? The closed labs cut their prices, or the open models close the last of the quality gap? Drop your prediction in the comments, and if this kind of breakdown is useful to you, you know what to do before you go.